your guys, what is the critical point?
I have no idea.
Okay, so this is the definition. A critical point is the argument of a function where the function derivative is 0 or does not exist. So I put the graph in this slide, and this is an example. I will show you where is the f prime of x equals 0 and f prime of x does not exist. So you can find this point, and the critical point is what is the x, not is the whole point, because the argument of a function is just x, where the x in the x-axis. So you just put this, and are you find some fault in this picture? No? It's weird. So, next slide. I will tell you, if you find like A, like this is a vertical asymptote. So A and E is not in domain. So this is the answer to this. Like A, E is not in domain. So we cannot say this is a critical point because A and E is not in domain. You can see this is an open circle and this is a vertical asymptote. So we find the final answer is when f prime of x equals 0 and the x can be b, d, g, and when f prime of x does not exist, as x can be c and h. So come back to look the definition. A critical point is the argument of a function. So this is the first important information. I explained that before. Argument, not the whole point, not x comma y, it's just x. It's a number. So sometimes we just say you will find critical points, and sometimes you will see the question is you will find the critical numbers. So it's the same mix. So this is the first information, and the second is when the derivative is 0 or does not exist. So if the derivative does not exist, you can also find the critical points. Not just this, the both, all the critical points. So, okay, if you already found the critical points, now we can classification to the local max, local min, neither. The local max also say local maximum, local min also say local minimum, and the neither also say neither local maximum or local minimum. So I put the local max, local min, and neither in there. Local max is like a peak in there, and the local min is like a valley. Sometimes the peak is smooth, or it can be sharp like a corner, and the local min also. And if this not like this deep, not look like a peak and not look like a valley, so it's neither. And also, where are the A and E? Because it's not in domain, so it cannot be critical points. So it cannot be local max, local min, neither. Here is the, I think it's not definition. It's, I think, just for, in other words, to explain the local maximum and local minimum. Local max, you can see the increasing. If you find the first derivative, you can see this is positive, positive, and the right hand is negative. This is negative. So it's from increasing to decreasing. I know the pronunciation is increasing, but I just want to stress increasing or decreasing. So this goes up and this goes down. Local mean is the same thing, but it's just from decreasing to increasing. And the critical number is in there. I just said it's in peak and this in valley. And it can be smooth or sharp, maybe curved. It's all okay. And this does not exist. Curved also. And this is 0, 0. And the local max is the peak. Local min is in the valley. So if neither local max or local min, maybe it looks like this. Not in valley, not in peak. So you can see it's also increasing or also decreasing. The sign not change. So it is neither. Okay, come back and remember local max, local min, and neither local maximum nor local minimum. It should based on the critical number, critical points. So if the point is not local point, you cannot say it's local something or neither something, because the first step you will find the critical number first. And so we can find this example. Okay, any questions before? So far? No?
Are you studying this in your coursework right now? Are you taking calculus?
It's from my calculus TA, but I draw it by myself.
Okay.
And put this picture in this slide.
Okay.
Or would you say why this is important? You know what I mean? Like how a normal person will use this, like.
Can you?
Like. Why this will be useful, like for someone to know?
Oh, I know. If you find this, it's the first step, because sometimes you will find the absolute maximum or absolute minimum, and you will like calculating the area and find the maximum area in the half circle, and you will use it. And this is just first step. And you use the critical points first, and then do second derivative test. And if it's not working, you will use first derivative test and find this and compare the value, and you can find the final answer. So it's just the first step. So it's the most important. If it's be wrong, so after the step is all wrong.
I think what Miguel is asking are what are the applications of this math in everyday life? How does this math, where do we see it? Is it in our cell phones? Is it where do we we don't know this math, but this math is helping something in our lives. What is it helping?
I just explain. If you want to like calculating the fence, like like there is a fence, and you want to use that fence to, like, circle an area,
Okay.
and the fence is expensive, and you want to find the minimum expensive, and you want to circle area.
Okay.
And
Okay,
you
so
will-
if you're building a fence, this would help you find the cheapest way
Yes,
to build that fence.
yes.
Okay.
It's like opti. I cannot remember because that is today we learned that.
Oh, okay.
Today we learned that.
Okay,
Okay.
all right. Thank you, Tina.
Okay.